Hello guys, once again this is Divya Pradhan and I'm going to talk to you about organic molecules. Well, first and foremost, organic molecules are very large molecules, okay? These large molecules are made up of the elements carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, CHNOPS. That's all there is to it. A combination of carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur make up organic molecules. Organic molecules are obviously very large and are always associated with living things, or, excuse me, why is my pen acting up? With living things. Or products from living things. So the basic organic molecules are carbohydrates, lipids, proteins, and nucleic acids. The most important characteristic of all organic molecules is, of course, that they exist as polymer. This word is right here and probably better than my own handwriting. Poly is many, mer is molecule. So what basically I'm trying to say is that all these organic molecules can exist as a polymer and made up of many single molecule or monomer. So like a wall made up of bricks, you don't have to study all the bricks, the entire wall, just study one brick and you will study the entire wall. For example, a necklace, a beaded necklace, a pearl necklace. You don't have to study the entire necklace. All I need to do is study one bead because the entire necklace is a repetition of these beads. So these polymers, that is all organic molecules, exist as polymers. So a polymer of a carbohydrate is called polysaccharide. A monomer of a polysaccharide is called monosaccharide. An example of polysaccharide would be starch. Starch that we eat in potato or rice is basically made up of just glucose molecules repeated one after the other. Okay, my handwriting is not coming out good, I'm sorry. Lipids is the polymer. The monomer is fatty acid and glycerol. In other words, many fatty acids. So this is a fatty acid, this is a glycerol. Here's another fatty acid and glycerol. And you join these together. So here's another fatty acid and glycerol. Here's another fatty acid and glycerol. So a chain of fatty acid and glycerol is nothing but lipid. A polymer of protein is obviously called protein, or it is also called a polypeptide. A monomer of a protein or a polypeptide is an amino acid. So a protein is nothing but amino acids joined by a peptide bond. We'll study this later, and you'll make a protein. Nucleic acid is a polymer. The monomer is a nucleotide. So each nucleotide now has three parts: phosphorus, a nitrogen containing base, and a 5-carbon sugar called the pentose sugar. So a nucleotide is a bead, and this bead, what I'm trying to tell you, has three parts: phosphorus, a nitrogen base, and a pentose sugar. Many nucleotides make up a nucleic acid. A nucleic acid would be like a DNA, would be like an RNA, would be also ATP, made up of nucleotides. Okay. Now there are a couple of terms of reactions that we see either when you're making or breaking an organic molecule. So the first one that we see is anabolism. Anabolism is a build-up reaction. So here what happens is, in this reaction, I'm writing reaction is Rx. In a build-up reaction, simple molecules join together to form a complex molecule. Okay, so there are 1, 2, 3, 4 molecules, simple molecules, and then you'll get a big large molecule made up of 4. So it's a build-up synthetic reaction, synthesis, DNA synthesis, protein synthesis is an anabolic process. Catabolic process is a breakdown process. So here what happens is, you are taking a large big molecule. So here's my large big molecule, and I'm breaking it down into small molecules. So it is an opposite of, so here you're breaking it down and you're getting all these small simple molecules. So catabolism, an example of catabolism would be, of course, digestion. Here you're breaking down a large complex molecule into simple small molecules. Dehydration. Dehydration is when two molecules, they unite, but how do they unite? By removing a molecule of water, you are uniting these two molecules. An example would be amino acid. Amino acid, when they join, give you one protein or a polypeptide. So then what happens is, you have a dehydration reaction, removal of water. Hydrolysis is just the reverse. You are taking a large molecule, and in the presence of water, you are breaking it down. So hydrolysis is the reverse of dehydration. Dehydration means removal of water. Hydrolysis means you are adding water, and therefore you are breaking it down. Enzymatic reaction is a reaction where we are going to use enzymes. So what enzymes are nothing but biocatalysts. These will change the speed of a reaction. Bio, living, catalyst means change speed of reaction. So what is changed? Speed of reaction is changed is an enzymatic reaction. Enzymatic reaction, most or all of our body functions are enzymatic reactions. You see, say for example, digesting. Digesting would be a very, very slow process, but thanks to enzymes that are there, now the reaction is so much faster. For example, what happens of enzyme would be in your mouth. The amylase is a good example of an enzyme. Now, don't worry about these enzymes. We'll study the enzymes more in detail later on. Right now, just understand any reaction which uses these biocatalysts, enzymes, is an enzymatic reaction. So I guess with this we come to the end of our presentation, and I thank you for listening to me. And if you have any questions or concerns, please make sure that you come and talk to me. All right? Thank you. Bye.